Hello friends, in last lecture we have seen the sign convention of SFD and BMD. I just want to revise it. Suppose, say this one is a beam and this one is a section of beam. Then on the left side upward is positive, on the right side downward is positive. So this one is a section of positivity. Similarly, again if we are considering the section, on the left side downward is negative, on the right side upward is negative. So this one is the section of negativity. When you talk about the moments, clockwise moments on the left is positive, anti-clockwise on right is positive. Similarly, anti-clockwise on left is negative and clockwise on right is also a negative. Now if you see this both the moments are acting like this, so it is bending the beam in this particular shape. This shape is termed as a sagging pattern, and sagging is normally termed as a positive bending. Similarly, this kind of moment will bend the beam obviously in this particular section, right? So this particular shape, which is termed as a hogging bending, or it is also termed as a negative bending. So normally when you analyze a simply supported beam, the shape of bending moment is something in a positive. When you analyze a cantilever beams, it is hogging or negative bending. So this much we have seen in the last lecture. This one is a basic concept which is required. Now we are starting with the cases. Say case 1. Case 1, I am dealing with a simply supported beam. So this one is a simply supported beam which is subjected to point load only, right? So my first case is simply supported beam subjected to point load. Right. Now suppose this one is a beam, say point A, point B. For simplicity, to make the problem more varietyful, what I am doing, I am assuming two forces, 1 and 2. Now say the value of this force is say 10 Newton and the value of this force is say 20 Newton. This force is acting at say 2 meter. This distance is say 4 meter. And this one is again 2 meter. Now we have to analyze this particular beam. Now if you remember in the last lecture I told you that you have to leave the space below the beam to draw the shear force and bending moment diagram. Correct? But how to find or how to calculate shear forces and bending moment at point A, B, C and D. Correct? So first what you have to do, you need to calculate the reactions. Reaction at point A and reaction at point B. Correct. Now how to solve this? Say this value of RA is unknown. Similarly this value of RB is also unknown. So what you have to do, you have to take the moment about the unknown. So take a moment about A is equal to 0. Now what you have to do, all the clockwise moments is equal to all the anti-clockwise moments. So see here, from this point this force is going clockwise, this force is also going clockwise and this force is going anti-clockwise. Correct? So as you remember, moment is what? Force into distance, a perpendicular distance. So when you are finding the moment about A, what you have to do, 10 multiplied by 2. That means I am taking a combination of these forces, 10 multiplied by 2 plus 20 multiplied by 4 plus 2, that is 6 meter from point A. is equal to 2 plus 2 4 plus 4 8. So 8 RB. Right? Now we have to simplify this. So RB, the value of RB, you need to calculate. It is coming 20 plus 120 divided by 8. That is 17.5 Newton. Now what you have to do, you have to take a second analytical condition of equilibrium, that is sigma Fi equal to 0. Now here we have taken a moment, that is force into perpendicular distance. Here we are taking the summation of force, and force are in terms of Newton, right? So here what we are doing, summation of Fi equal to 0, this indicates all the vertical forces must be equal to all the downward forces to keep the section in equilibrium condition, right? So for this we'll write the equation as RA plus RB is equal to 10 plus 20, right? So on simplifying, put the value of RB from here, that is 17.5. So when you are solving this, you will get the value of RA as 12.5 Newton. I hope this part is clear, how to calculate R and RB. This already you studied in a previous semester in your engineering mechanics. How to calculate reactions. So RA is 12.5 and RB is coming 17.5 Newton. Don't forget to write the units, right? So this one is a calculation of reaction. Now we are starting with the shear force calculation. In case of shear force, what you have to do, shear force calculation. Just look at this. What you have to do, you have to assume a section. This section is an imaginary section. Suppose you need to calculate shear force at point A, right? So when I am assuming shear force at A, I am assuming the section just on the right of A. When I am assuming a section just on the right of A, either you can assume the left part of the section or you can assume the right part of the section. The answer coming from both the sides will remain same, whether you take a section from point A or you take a section on the right side, that is towards the B, correct? Suppose for your simplicity I am showing you the section. Say this one is a section which you are assuming. No need to show this particular section in the examination. This one is just for your understanding. Suppose you are assuming a section here. I am assuming the left side, as there are less number of forces on the left side of the beam. So I am assuming the left side. So left side, you remember the sign convention? On the left, upward is what? Positive, right? So on the left, this force is upward and the magnitude is 12.5. So shear force at A is equal to RA is equal to 12.5 Newton, as it is acting upward on the left. This force is positive. Let us check what if we are considering the right side of the section. If you consider the right, you remember sign convention, downward is positive, upward is negative. So 10 plus 20 is 30. 30 minus 17.5, again you will get the same answer as 12.5. This proves that either you go on the left of the section or right of the section, the analysis part will remain same and the answer will remain same. Now you have to move further. Shear force at C, right? Remember, when the one point is loaded with two loading conditions, like if suppose at this point you have a UDL along with the point load or UVL along with the point load, then you have to take left and right both the sections. But here you have an effect of only one point, right? So you are considering only section either on the left or on the right. Here if you assume the section on the left, the impact will remain same because there is no loading condition between AC. So what you have to do, now we have to shift your this section here, right, just on the right of C. Now when you are moving this section, Now on the left of the section there are two forces, on the right of section there are two forces. So you go any side as per your convenience, you will get the same answer. Suppose you are going on the left, then 12.5 is upward and 10 is downward. So 12.5 minus 10, you will get 2.5, positive answer. If you go on the right, 20 is downward, on the right downward is positive. So plus 20 minus 17.5, your answer is again 2.5. Right? So answer is same, you go in whatever way. I am showing you here the shortcut. What you have to do, you have to take the previous answer, that is 12.5, and next load ka direction you have to assume only left side ka, right? That means upward is positive, downward is negative, clockwise is positive, anti-clockwise is negative. So you have to take the previous answer, and next load is in downward direction. So just you have to do the minus, because minus is negative. So 12.5 minus 2 minus 10, you will get 2.5 Newton, which is positive. Again I am moving my section from C to D, just on the right of D. Again I am using the same technique. I am taking the previous answer, that is 2.5, and this 20 is acting downward, that is minus 20. So my answer is minus 17.5 Newton. And last, shear force at B is equal to, my previous answer is what? Minus 17.5, and the direction of next load is upward. Upward is positive, so plus 17.5 and is equal to 0. Remember, in the last step your answer is always equal to 0. Now how to plot the shear force diagram. What you have to do, forget about these sections, right? This one is just for your understanding. Forget about these sections at C. Try to make this diagram simple so that there will be a less number or a less confusion during the examination while you are plotting the shear force or bending moment diagrams. What you have to do, you have to project each point. You have to take the projection of each point like this, right? Draw one line which represents 0 shear force. Now look at here, shear force at A is what? 12.5. I am assuming above the line is positive, down the line is negative. So first I am plotting 12.5 upward. No need to plot with respect to scale, just you have to show it proportionally. No need to plot on the graph, right? 12.5 positive. Now there is no load intensity between AC, so line will go straight, right? Then my next shear force is 2.5, so 2.5 suppose somewhere here, right? So I am drawing a line downward, 2.5. Again there is no load between C and D, so I am drawing a straight line. I am indicating my magnitude here, 2.5 Newton, right? Then at point D you have a force as minus 17.5 that goes down, something like this. Say 17.5 Newton. Draw a straight line as there is no load intensity, and last value is 0. These values are positive and these values are negative. So this diagram represents your shear force diagram, SFD. Either you can mention units here or just you mention the values here and write SFD into bracket in terms of Newton. If you are writing here Newton, there is no need to mention the units here. It is self-understanding that units will remain constant throughout the diagram. This is all about the shear force calculation. The last part is bending moment calculation. Now when you are calculating bending moments, remember bending moments at the end points for simply supported beams are always equal to 0. I am repeating, bending moments at the end point of the simply supported beam is always equal to 0. Why? Because if you assume the moment from this point, you have to assume either the left of beam or right of beam. If you assume the right of beam, there are number of forces, but when you go on the left side, there are no forces, correct? And I told you, in case of SFD and BMD, either you go on the left or on the right, the calculation part will remain same. That means your answer will be going to coming same, right? So here for simplicity, there is no load on the left of A. Similarly, no load on the right of B. So straight away I am writing without wasting my time. Moment about A is equal to moment about B is equal to 0. Now I remained only with 2 points, moment about C and moment about D. So moment about C, if I go on the right, I have 1 and 2 forces. So I have to analyze 2 forces. So instead of going on right, I will go on the left of C. When I take the moment about this point, on the left, this force is what? This force is clockwise. This force is rotating clockwise. So on the left, clockwise is what? Positive, correct? So plus 12.5 multiplied by perpendicular distance, which is equal to 2 meter. Right? So this moment will come 25. Write the respective unit. This one is in Newton and the lengths are in meter. Similarly, moment about D. If I take the moment about D and I'll go on the left, I have to analyze 2 points. So instead of going on left, I am going on the right, because there is on the right hand I have only one force. On the right, this force is going anti-clockwise. Now how to see this, whether the force is clockwise or anti-clockwise? So what you have to do, you have to assume these two fingers, the thumb and the first finger, as a rounder. Right? And assume that this one is the tip of the rounder and this one is the pencil. Put the tip from which point you are finding the moment, right? Either from B or D or C or A. Suppose I am finding from D, right? Keep your pencil on point B and start to rotate this force, right? The curvature in which, or the path in which the force is rotating, is your final moment ka direction, either clockwise or anti-clockwise. So here you can see this one is my rounder. I am rotating this force. This is going anti-clockwise, correct? So anti-clockwise on the right is positive, correct? So 17.5 into 2, correct? So 17.5 into 2, when you multiply this, you will get the moment as say 35 Newton meter. Now what you have to do, you have to plot the bending moment diagram. As there is no negative moments, what I am doing, I am drawing at the baseline. Otherwise you have to plan according to the page length, correct? But here all the moments are positive, which will going to come on the upper side of the line. So what you have to do, at C you have to plot 25, at D you have to plot 35. So here you have a bending moment of 25, here you have a bending moment of 35. And remember, I told you the shapes, how it goes: straight line, what is the order? Inclined line and parabolic curve, right? And I told you in the last lecture that you have to follow this path, right? If you are drawing inclined line in a shear force, bending moment is compulsory parabolic curve. You cannot go in a back direction. You cannot go reverse. Remember that? So what does it mean? This straight line. Now look at here. All the shear force are having the straight lines in between the forces. Correct? When the shear force is a straight line, what is the nature of bending moment? The next one, that is the inclined line. So what you have to do, you have to join this by the inclined line. You have to join this by the inclined line, and you have to join this by the inclined line. As in between here you have straight lines in the previous diagram. So in BMD, in respective BMD, you have straight ka conversion into incline as per this particular sequence, right? If suppose यहाँ पे कहीं पे inclined line होता like this, something like this, then this is parabolic curve, something like this. But we'll see that in the different case whenever it will come. But as of now, you remember, here you have a straight line. So as per order, after straight line, I am going to the inclined line. Again, both the values are positive, so I am writing here plus. I am mentioning here BMD in Newton meter, right? As I am mentioning the unit here, no need to mention the units here. So this is all about the first case of shear force and bending moment diagram where simply supported beam is subjected to 2-point loads only. There are no UDL, there are no UVL. Hope you liked the video, you understood everything and each part of the calculation. Still, if you have any doubt regarding the solving part or analysis part, you are free to ask in a comment section. With this, I am winding up today's lecture. Thank you so much for your attention. Please like, share and subscribe. Thank you.